Welcome to episode 16 of Programming Problems, where today the elves are playing a game of look and say for the 10th day of Advent of Code, 2015. In this game of look and say, an elf gets presented a number and he needs to read the sequence aloud. What is being said aloud is itself the next sequence. For example, 1 can be read as 1-1 because there is only a single 1. Now, according to the rules, the next sequence then is 1-1. If we see the sequence 1-1, then this is read as 2 1s, so the next sequence is 2-1. 2-1 then is read as 1-2, 1-1. The next sequence then is read as 1-1, 1-2, 2 1s, and so on. For the puzzle then, we are given some number as our puzzle input, and we are asked to give the length of the resulting sequence after 40 rounds of look and say. Do you already see how you can program this algorithm? Let's have a look at today's solution. We shall start with this sequence of 1-1-1, 2-2-1. The first step of the game requires us to identify groups of numbers that are the same. In this case, that is visualized as these 3 blocks. Then we have to translate each block as if we were reading it out loud. The first block consists of 3 1s, so this segment is translated to 3-1. Next up is the segment with 2 2s, which remains the same. The last segment has 1-1. Concatenating the results of these segments is the new sequence while playing the game. Now let's write some code for solving this. We shall start by first splitting the sequence into segments of characters that are the same. There are, of course, many ways to do this, but in this example, we shall iterate over the characters and we'll collect our segments character by characters. Note that this assumes that we have our sequence as a string. We will kickstart our algorithm by initializing an empty list to hold all the segments, and the first segment shall start with the first character. From this point, we will iterate from index 1, because the first character is already in our current segment, to the last character in the string. Then we check. Is the current character in the input string the same as the last character in the segment that we're currently building? If it's not, then we know that we switch characters, and thus the segment that we were building has ended. In this case, we append the segment to our list of all segments, and we start building a new segment. Otherwise, if those characters are the same, then we simply append the character to our current segment. Once we're done looping over all characters, we'll be in the scenario where we will have a segment that was not yet appended to our list of segments. So that's what we'll do here. Finally, we of course return our list of segments. Then, for the second part of the algorithm, we need to convert every segment to its new read-aloud version. In this simple function, we just take the first character of our segments as the token, which will be the thing that we are counting. Then, the length of the segment is how many of those tokens there are in the segment. So, for example, 1-1-1 becomes 3 1s, where 3 is the count and 1 is the token. And that's it already. We get an input number, which we can read as a string, and we then split that into segments. Then, for each segment, we simply convert it, and we can join the results into our new sequence. After doing this 40 times, we should have the resulting string, of which we can just return the length. Now, today's part 2 is not very exciting. We are being asked to perform the same game, but for 50 rounds instead of 40. And you know what? Running for 50 rounds is generally still very feasible with the algorithm which we've just seen. And that makes for a pretty short day 10. 2 more stars in the bag, and I look forward to making the next video.